It is a Wednesday, May 13th, and this is our Uniform FRQ probability binomial normal sibling distribution and checking conditions, okay?
All right. For each day that Sasha travels to work, the probability she will experience a delay due to traffic is 0.2. Each day can be considered independent of the other days. That's going to be important. Flashback, what does it mean to be independent? It means you can multiply the two probabilities together willy-nilly, no problem, no worries in the world, and you will get the intersection of A and B. All right, so independent means and problems. You can multiply them together. Anywho, for the next 21 days, Sasha travels to work. What is the probability that Sasha will experience a delay due to traffic on at least 3 of the days? So see what part A does? Part A adds this layer to this probability problem where we're setting a trial, right? We're going to do this for 21 days. That's it. So since we have an n, right, the number of trials, it's now set binomial, right? Set number of trials. The probability 0.2 stays consistent. It's independent each day. So that's the probability of delay. All right. So what is the probability she will experience delay on at least 3? So let me get my number line going in my head. 0, 1, 2, 3, 4, all the way up to 21 days. At least 3 means we're going this way. Ruh-roh, T.I. Joe doesn't speak greater than. He's only programmed to speak less than. So you got to get creative. Start with the whole thing, right? All of them is 100%. And we're going to get rid of 210. So we'll do our countdown 210 right here. Getting rid of 210 leaves all the other probabilities for you, which is 0.82. So the probability of delay on at least 3 of the 21 days is 82%. All right, so to get credit here, they were looking for you to define that it is binomial now because you have a set number of trials and you have the same probability each time, right? Every day that she goes to work, the probability hasn't changed. The next thing they were looking for is for you to show the boundaries, right? What were the boundaries? Where were you on your number line? Then, of course, the third thing they're looking for is the answer. Could you calculate it correctly? And if you have all 3 things, E, partial, means you only did 2 out of those 3 things. All right, so if you don't have that T.I. Joe, maybe you can ask a neighbor. Maybe they have an extra T.I. Joe. If you have these smaller calculators, if you go to second data over to distributions, they do have binomial options. And of course, there's online calculators you could use if that pops up. All right, part B, boy. What is the probability that Sasha's first delay due to traffic will occur after the 5th day of travel to work? Be careful on part B. All right, part B is no longer looking at 21 days. All right, 21 is gone. All right, part B is like start over, new question. What's the probability that it will occur after the 5th day? This is an example of geometric, right? We don't have a set number of trials. They didn't tell us how long or how many days Sasha was going to watch this. All right, so when you don't have a set number of trials, this is just classic probability. All right, so if we have delay after the 5th day, that means on the 1st day, there's no delay. 2nd day, no delay. 3rd day, no delay. 4th day, no delay. 5th day, no delay. It's after the 5th day, right? After the 5th day that delay happens, all right? So no delay. So the probability of no delay, let's see, they didn't give that to us. They gave us the probability at the beginning, right, in this opening paragraph that delay is 0.2. So the complement to 0.2 is 0.8. So 80% chance of no delay. So with that being said, we've got 80% chance here, 80% chance here, 80, 80, 80. So that's 1, 2, 3, 4, 5 80%. So 0.8 to the 5th gives me my answer of 0.32768. So the probability that her first delay is after the 5th day is 0.32768. That one was tricky. 2 things they were looking for, correct answer and some work. Did you have to show all this? No, but they wanted to see your thought process that got you to your answer. If you have your thought process but the wrong answer, they'll give you partial credit. All right, so it's always good to show your work. Part C. Consider a random sample of 21 days. Okay, so now we're back to a cap. All right, random sample of 21 days. For the proportion of those days that she will experience a delay due to traffic, is the sampling distribution of the sample proportion approximately normal? Ah, all right. So ring, 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 ring. Who is it? Who is it? It's Jake from Stat Farm. Discount double check. All right, we got to make sure we have enough successes and enough failures and a sample size 21 for this. All right, so 21 times the probability of delay, right? We're using the delay again, is 4.2. Aw, fail. 4.2 is not greater than or equal to 10. I checked the other side just out of habit. It wasn't needed, but checking the failures, we had 16.8, which was good to go. Anywho, they want to see the NP greater than or equal to 10. They want to see that you make note that it is not greater than 10. And then your conclusion, the sampling distribution of the sample proportion is not approximately normal, right? It failed that check. There you go. So hopefully you've got that college credit going on. See you later.